Namaste and welcome back to the DSA classes. We were discussing on the concepts of arrays, and today guys I'm going to be introducing another commonly asked program on arrays which you must and should know, which is rotate an array. Now what do you mean by rotation of an array? Now this is very important. You will be using this concept in multiple other programs in the future, so it's a very commonly asked question and you must know how to rotate an array. First and foremost, what do you mean by rotation? Please understand. Guys, I am assuming this is the array that is given to me called as A. In that I have 1, 2, 3, 4, 5 as my elements. Okay. Now what I want to do is, I want to left rotate this array by 1. So see, I am showing you the direction. Okay. Counterclockwise I want to rotate it by 1. Now you can rotate it clockwise, which is called as right rotation, or you can rotate it counterclockwise, which is called as left rotation. I am doing it counterclockwise, okay? And I am going to rotate this array by ones. Now what happens when you rotate this array by ones? Very simple. First and foremost, what happens is 1 gets rotated, so it will come outside. It will come outside, and where will it go if you ask me? It will go in the end. So there 5 is already there, so I am just keeping 1 below that. Then what happens is, every other element gets pushed 1 position to its left. So 2 comes here, 3 comes here, 4 comes here, 5 comes here, and naturally 1 will go sit in the end. So our original array, when left rotated by ones, will look like 2, 3, 4, 5, 1, like this. Any confusion? Great. I am bringing it back to its original style. Now how can we achieve this as code? Now my logic is simple. I want to left rotate my array by ones, just by ones. What could be the logic for it? Now, the most simple way to approach it, the naive approach, the unoptimized approach, let's look at it first. So this is the naive approach, okay? So the naive approach, what I will do is, first and foremost, I know the first element will come and sit at the end. That is obvious if I left rotate it by ones. So what I will do is, I will create a variable called as temp. And the zeroth element means first element, I will store it inside temp. So see, 1 gets stored inside temp. Same thing as code I am writing, a of 0, I will store it inside temp. Fine, great. Now what we have to do is, from the second element onwards till the last element, we must now shift its position, shift their positions, 1 position to the left. That is what we have to do. How will I achieve that? Simple. I will create a loop starting from the second element. So I starts from the second element. This loop should go all the way till the end. So see, I will tell for I beginning from 1 to the length of A. Length of A means till the end. Now what will I do inside this? Simple. If wherever the ith element is, I must shift it 1 position behind. Or if wherever I is, I minus 1 position it should go to. That's all I should do. Write that code. A of I, please assign it to A of I minus 1, I minus 1. If I do that, A of I is 2, right? 2 I am assigning it to A of I minus 1. 1 minus 1 is 0. So say 2 gets assigned here. I moves forward. 3 gets assigned here. I moves forward. 4 gets assigned here. I moves forward. 5 gets assigned here. Any confusion till there? Now what about the last element? Now that last element should be our first element. Now where is the first element? Inside temp. Which means now I will move forward. Looping will stop. And once I come out of the loop, what I will do is, in temp I have the first element. First element should be stored at the last index. So how will you write that in general? Simple. I'll say whatever is there in temp, assign it to A of, I want the last index. How will you get the last index? Length of the array is 5. 5 minus 1 is 4, that is only your last index. If length of the array was 10, 10 minus 1 is 9, that will be your last index. In other words, length minus 1 is always the last index. So, A of length of A minus 1. That is how you can write it in general. Any confusion? So, this is a simple code to rotate it once. I hope you are able to think. Now, will this work is the question. Let's go explore. Alright, so now in Java the code is quite simple. I've created a static function called as rotate, which obviously is not going to return anything because we are going to rotate in the same array. It's going to accept an integer array called as A. Within the main method, I have already initialized an array A which has 5 elements, 1, 2, 3, 4, 5. Now I need to rotate it by once, right? So see how I will do it. I'll go inside this, and according to our logic, the first element, which is A of 0, I will store in a temporary variable. So I'll tell int temp equal to A of 0. Yeah. Leave space on the left side of assignment. Yeah. Right. And next, in the next line, I am going to go and now run a loop. So I will tell for, and you know, int I equal to 0, I less than a dot length, and I plus plus I will tell. So basically, I am running a loop over my array. Now, here we have done a mistake. I should not begin from 0. I should begin from the second element and go to the last element. So that's what I am doing. I'll make it as 1. Right? Yeah. Now inside that, what I will do is A of I. A of I will assign it to A of I minus 1. So we're just shifting it one position behind. That's it. Okay, put semicolon. That's it. So once I come out of the loop, I will come outside the loop. Once I come outside the loop, now all the elements till the end would have been placed, right? So 2, 3, 4, 5. Now the last element I have to put my first element which is inside temp. So I'll tell A of, now I want last index. Last index is nothing but A dot length minus 1. That is only the last index. Into that I will store temp. That's about it. Now I'll come inside the main method and I would just like to print the array before and after rotating it. So what I will do is I'll just run a for loop, so you can just auto complete it. Yeah. And now inside that I will just tell system.out.println, and I will just tell A of I like this. Yeah. So you can make it as print and just leave a space after A of I. Yeah. I'll just attach a space so that it comes in one line. Yeah, I'll come outside. I'll just tell one sysout statement so control comes to the next line. Yeah, and now this is before I am rotating. Now I will call the rotate function. I will call the rotate function, and I will pass A to it. That's it. Next, what I will do is semicolon. I will now copy this entire for loop, paste it again because I'm just printing it after rotation as well. Good. Any confusion till here? Let's see whether really rotation would have happened. If in case I go execute it, one can clearly notice that this is 1, 2, 3, 4, 5 before rotation, 2, 3, 4, 5, 1 after rotation. So clearly, successfully we have rotated the array once. Now, what if the question says that rotate the array by D places? Now we have rotated by one place. Every element was rotated by one place each. What if they ask 2 places, 5 places, 8 places? I hope you are able to think. How are we going to do that? Well, it's very simple. Let's explore that as well. So now, the previous program rotated the array by just once. But what if the question changes and they ask you to rotate the array by a certain number of times? What do I mean by this? This is my original array. Okay. Let us assume that the number of times the array has to be rotated by is denoted by a value k. Okay. So this is k, and k is 0 because I have not rotated the array even once. So k is 0. Now I am just creating a copy of the array. Now let us assume k is 1. 1 means I am rotating the array once. If I rotate it once, how will it look like? Very simple. First element will come to the last, rest everything will be pushed one position to the left. So 2, 3, 4, 5, 1. This is how it looks when you rotate it once. Okay. What if I rotate it 2 times? If I rotate it 2 times, then very simple. Look at the original array only. Take the first 2 elements, put it at the end. Rest of the elements, shift it to the left by the number of times you are rotating, which is 2 times. So see, if 4 gets, if 3 gets shifted 2 times, 1, 2, 3 comes here, 4 comes here, 5 comes here. So 3, 4, 5, 1, 2. Any confusion? What if I rotate it 3 times? If I rotate it 3 times, then take the first 3 elements, place it at the end. Rest of the elements, shift it by the number of times you have to rotate, in this case 3. So 4 comes here, 5 comes here. Any confusion till there? If I rotate it 4 times, take the first 4 elements, place it at the end. Then whatever is remaining, shift it to the left by the number of times you have to rotate. So that is 1, 2, 3, 4. 5 should come at the beginning. That is what happened. Now I want you to focus. What if I shift it, or what if I rotate the array by 5 times? Think about it. If I rotate it by 5 times, anybody with common sense will tell me, sir, take the first 5 elements, place it at the end. If I take the first 5 elements and place it at the end, then it becomes same as the original array. In fact, if you rotate an array by the number of times which is equal to the size of the array, there is no effect of rotation. It is equivalent to not rotating at all. So it is the same. I hope you are able to think. Now I want you to focus. What if I rotate it 6 times? Now the number of times I am rotating for the first time has become greater than the number of elements I have. So far it was equal to the number of elements or lesser. Never greater. Now it is greater. If I do this, how will it look like if you ask me? This is how it will look like. 2, 3, 4, 5, 1. I hope you are able to understand. 2, 3, 4, 5, 1. This is how it will look like. Now I want you to understand and observe something very important. This 2, 3, 4, 5, 1 is same as this 2, 3, 4, 5, 1. Which means rotating my array 6 times is equivalent to rotating it just once. Because correct, this is once, twice, 3 times, 4 times, 5 times it will come back to the original array. 6 times will be equivalent to rotating it once, which is equivalent to this. As simple as that. This is a very important observation because it will help us optimize our code. Similarly, if you look at the last, let us assume I take one more example where I am rotating by 7 times. If I rotate it by 7 times, this is how my array will look. And if you look at this 3, 4, 5, 1, 2 is similar to this 3, 4, 5, 1, 2, which is nothing but rotating it how many times? 2 times. And correct. 7 times means 5 times if I rotate, it will come back to its original way. Then rotate once, rotate twice, equivalent to rotating 2 times. So, if I ask you to rotate 7 times, do you really have to rotate it 7 times or do you have to rotate it only 2 times? 2 times. If I ask you to rotate it 6 times, should you actually rotate it 6 times or do you have to just rotate it once? You have to just rotate it once. How are you able to think? If I ask you to rotate it 5 times, then do you have to rotate it at all? No, not required. Hence, this k value, we have to write code in such a way that the k value automatically gets transformed. If k is 5, or in other words, if k is equal to the length of the array, automatically k from 5 should become 0. If k is 6, it should become 1. If k is 7, it should become 2. If k is 8, it should become 3. So on and so forth. How can this k value be transformed? Prior to rotation, before rotation, so that unnecessary rotations can be avoided. If you ask me, it's very easy. All you have to do is look and listen carefully. K value is 0. I am going to divide 0 by the size or the length of my array. What is the length of my array? 5. But I will not use slash, I will use modulo because I want remainder. 0 mod 5. 0 when divided by 5. What is the remainder? 0. Equal to k value only. Great. If k is 1, 1 modulo 5. What is the remainder? 1. Same only. 2 modulo 5. 2. Same only. 3 modulo 5 is 3. Same only. 4 modulo 5 is 4. 4 only. Now watch it. 5 modulo 5. 5 when divided by 5, remainder is how much? 0. How many times am I supposed to actually rotate it? I don't have to rotate it only. K value transformed to 0 and that is what I want. Brilliant, isn't it? Similarly, 6 modulo 5. 6 modulo 5 means, what is the remainder? 1. And if someone asks me to rotate it 6 times, actually I want k to become 1 because I should only rotate it once. I hope you're able to think. Beautiful. 7 modulo 5, what is the remainder? 2. And only 2 times I have to rotate. So do you see how I could transform the k value? So in general, what should I do? K modulo length of a. If I do k modulo length of a, then that k is actually the actual answer or the actual number of times you have to rotate. So this is one observation I want you to keep in mind. Now guys, nobody ever told that the number of times you have to rotate will be a positive value. Nobody told. Nobody told it has to be a positive value. Nobody told. It can be a negative value. What do you mean, sir? You may ask. Assume k is minus 1. Sir, if it is minus 1, what happens? You may think. Very simple, guys. If k is positive, then you are doing left rotation. If k becomes negative, it means direction of rotation is changing. From left, it is now going to become right. I hope you are able to think. From counterclockwise, it is going to become clockwise. Now, clockwise rotated by ones is what it means. If clockwise I rotate the original array by ones, then what happens is 5 will come here because it goes outside, comes here. Rest all the elements will be shifted one position to the right, which means 1, 2, 3, 4. This is how it looks like. I hope you are able to think. Now, k is minus 1, this is how it looks like. But this 5, 1, 2, 3, 4, 5, 1, 2, 3, 4. So, rotating by negative 1 is equivalent to rotating 4 times. So, how can that minus 1 be made equal to 4? How are you able to think? So that also simple mathematical relation we can write. Watch it. I will take the number of times I should rotate minus 1, and this time instead of dividing, I will add it with the length of my array. What is the length of my array? 5. Minus 1 plus 5 is how much? 4. Our k value should become 4 because minus 1 is similar as this. Similarly, if in case my k value was minus 2, then minus 2 plus 5 is 3. It is equivalent to rotating it 3 times. So what is my second observation? That if in case k is negative, then I will update the value of k by telling k plus length of a. So these are the two observations which you must keep at the back of your mind. Any confusion till this point of time? Yes sir, we understood. Now the question is, okay sir, how are we going to write this as code? Well, for that, let me show you. So now watch it. Whatever code we have written, we can reuse it. What do you mean, sir? You may ask. Scroll on top. As you can see, this is my rotate function. The rotate function that we have written is capable of rotating an array exactly by once. But every time I call this function, array will get rotated by once. Which means if I call rotate function 5 times, array gets rotated 5 times. If I call this 6 times, array gets rotated 6 times. So no matter how many times I want rotation to happen, if that many times I call rotate function, matter is over. How are you able to think? So how are we going to do that? Simple. I'll just change the name of this function, and in capital I'll just put 1. Yeah, not underscore, just put like camel case. Rotate 1, I'll call this as. Any confusion? So what does this function do? It will rotate exactly by once. Now what I will do is I'll come out of this function, leave some space, bring it down. Yeah. And there I'll just create a function. I'll call it as static void rotate. Okay, sir. Inside this, what will you do, sir? Inside this, I will accept my array which has to be rotated, and I'll also accept an integer value k, which is the number of times rotation must be done. Good. Now I'll come inside that, and there what I will do is just run a for loop. I will tell for. Now, how many times should I rotate? K times. So k times I'll run a loop. So I'll tell for int I equal to 1 till I less than equal to k, I plus plus inside that. Now you know, how many times will this loop execute? K times. If k is 5, 5 times. If k is 10, 10 times. Now 10 times I should rotate. For that I'll call this rotate 1. And I will just pass a to it. That's it. That's it. But if you just write code like this, it is not optimal, because you know, if k is 5 and the size of my array is 5, I actually don't have to rotate only, but this will simply rotate it 5 times. How are you able to think? If k is 10, then also I don't have to rotate, Because you know 10 times means 5 times if I rotate same thing, again 5 times if I rotate same thing. So 10 times if I rotate is equivalent to the original array, but simply 10 times this will call it. So what is the solution we found? I'll go on top of the loop and there leave one more line space. Yeah, there I will go and I will tell, first and foremost what I will do is I will check if in case k value, or before that I will just modify the k value, remove that if condition. I will just tell k equal to k mod length a dot length semicolon. So you do. If you do this, then actually how many times you are supposed to rotate, you will get it, and that's what I just taught you. Also check if k is negative. If in case k is less than 0, if k is less than 0, then you know what you have to do is modify k by telling k is equal to k plus the length of the array, a dot length. This is what we understood. So these two lines will ensure a lot of unnecessary execution of code can be prevented. Any confusion till here? Then scroll down, rest is the same. In the main function I am creating my array, I am just before rotating printing it, after rotating printing it. If in case I now go here, rotate function should now have a k value also. So let us assume I say I want to rotate it 3 times, right? So now if in case I execute it, then one can notice like this, 1, 2, 3, 4, 5, 3 times you wanted to rotate. So see, take the first 3 elements, put it here, move everything to the front, 4, 5, 1, 2, 3, perfectly it works. I'll go there, change the k value, make it as 5. Now if I make it as 5, actually internally rotation would have not happened only, because you need not rotate, it is the same. So if I execute, perfectly you can notice it is the same. If I make k as 10, then also it should not change. If in case I execute, then you can see 1, 2, 3, 4, 5. If I make k as 7, then actually 7 means how many times you should rotate? Just 2 times. That is what it means. Because if you take 7 mod 5, what you will get is 2. Only 2 times you should rotate. So if in case I execute, as you can notice, see 1, 2, place it here, rest write it as it is, equivalent to 2 times rotating. How are you able to think? If I make k as minus 1, then it is equivalent to rotating 4 times. Let's see whether that happens. Yeah, take the first 4 elements, place it in the end, 5 comes here, equivalent to 4. Perfectly, it works. Any confusion? However, if in case I scroll little bit on top, yeah. Now you can notice that here there is a loop, and this loop is calling a function which internally is also looping. How are you able to think? Now this function is always going till the end of the array, from the second element till the end. But in general, can I tell if n is the length of the array, n times this loop is working. So this is working n times. On top here, k times it is working. So k into n is your time complexity, big O of k into n. Obviously this is not an efficient time complexity. Can we make it better? Can we make it better? Yes, you can. In fact, to rotate a given array by k times, there is an algorithm which has already been developed. And these algorithms are algorithms which you must and should know, because it will save you a lot of time and make your code very efficient. Sir, what is that algorithm, sir? And how does it work? Let me show you. Alright, my friends, now let me show you the efficient approach to rotate an array by a given number of places, right? Now I don't want to call that rotate one function multiple times. It is increasing my time complexity. So programmers came up with a beautiful logic, a very smart solution, an efficient solution. Now the base or the core of this solution is reversing an array logic. Now I've already taught you reversing an array in this video. If you don't remember, please go watch it. I have in detail explained how you can reverse the elements in an array. Now I'm going to use that logic here. Okay. Now listen to me and listen to me carefully. Assume this is the array, my friends. Okay. Now I have 10, 20, 30, 40, 50, 60, 70, 80, 90. Now assume k value is 4. I have to rotate this array by 4 places. Now I am bringing the final output here for you. The final output, how will it look? Take the, because by 4 places means take the first 4 elements, place it in the end. Remaining elements will now get shifted by 4 positions to the left, which means 50 will get shifted, it will come here. 60 will get shifted, it will come here. Similarly, 70, 80 and 90. So this is your final output if you rotate this array by 4 places. Now see how I will use my algorithm to convert this into that. How will you do that, sir, you may ask? It's very simple. What I will first do is, I want you to understand, I will now partition this array into two parts. What are those two parts, you may ask? Now, if I want to basically rotate this array by 4 places, what did we do? We took the first 4 elements. And we placed it in the end. Which means this first 4 elements is one part. Then the remaining we shifted by 4 positions, and that is what we got here. So that is my second part. So I'm just drawing a line there for you. First part, second part. Okay. So first part is from here to here, second part is from here to here. Any confusion? Now see what I will do. I will reverse both the parts. What do you mean, sir? If I reverse this first part, then what I will get is 40, 30, 20, 10. I reverse the first part. Now if I reverse the second part, what will it look like? 90, 80, 70, 60, 50. Okay, sir, but this is not the right answer, sir, you may ask. Correct. I am creating another copy. Now watch it, I rotated the first part, I rotated the second part. Now I will rotate the whole array. If I rotate the whole array, I will get 50, 60, 70, 80, 90, 10, 20, 30, 40. Now look at this and look at this. Same or not? Sir, what is this magic, sir? Please explain us once more, you may ask. It's very simple, guys. First thing is, you must partition your array into 2 parts. You must partition it into 2 parts. Now, how will you partition it? Very simple. K value will help you partition. Because if K is 4, my first part is from the first value, 0th index, till this index, 3. Now, how will you get this 3? Look at K value, it is 4. Till which index should you go? 3. How will you correlate 4 and 3? 4 minus 1. Or in other words, K minus 1. Which means my first part is from 0 to K minus 1. Would you agree it matches? Now my second part is all the remaining elements. Remaining elements means from 4th index to the last index. How to get last index is simple. But how will you get this index? Simple. What is K value? 4. From 4 only you should start. So from K to last index means length of A minus 1. You know how to find the last index. Length of the array minus 1 is only a last index. So you got your 2 parts. First part is from 0 to K minus 1. Second part is from K to length of A minus 1. I hope you're able to understand. Now, you got 2 parts. Now you create a reverse function. How to create it? I will show you. Now I'll tell the reverse function, hey reverse function, start from 0 till K minus 1. This part, please reverse it. If it reverses it, what will I get? 40, 30, 20, 10. Again, I will call reverse function and tell, hey, reverse function is reverse from, that is your starting point, till the last index, length of A minus 1. It will reverse it. I will get 90, 80, 70, 60, 50. Good. Part 1 got reversed, part 2 got reversed. And that is what I am showing. Reverse the array A from 0 to K minus 1, start to end. Reverse the array A from starting from K, ending at the last index, length of A minus 1. 2 times I will call reverse. If I call reverse 2 times, both my parts got reversed. Now, this complete array I want to reverse. I want to reverse the complete array. How are we going to do that? If you ask me, it's very simple. Again call reverse. This time, from starting till ending, I want to reverse. So I will tell reverse the array A, starting from 0th index till the last index, means what? Length of A minus 1, which means from here to here it will reverse. And if it reverse, what will you get? Reverse of this 50, 60, 70, 80, 90, 10, 20, 30, 40, which is equivalent to rotating the original array by 4 places. As simple as that. So ultimately what you had to do, find the 2 parts of your array and call your reverse function how many times? 3 times. First time, second time, third time. Reverse part 1, reverse part 2, reverse the entire array. That's it. That's it. Sir, How will this look like code, sir? And will it really be optimal if you ask me? Let's go explore. Alright, my dear friends, now let's implement the algorithm, okay? So if I scroll on top, first of all, I don't want this rotate one function, I'll remove that. Now inside this rotate function, all this k mod, all that is fine, but I'm calling rotate one function. I don't want this, I'll remove this. Now, reversing is the core logic of our program. So what I'll do is I'll go on top of this rotate function, and there I'm going to create a static void function called as reverse. Static void reverse will accept my array. And from which point to which point reversal should happen. So start and end. Int start and int end. Now I'm not going to explain the logic of reversal to you because I've already explained it. Please go watch the video. Anyways, I'll tell as long as start is less than end. Inside that, this end you can make it as. I'll just go there and I will create a temporary variable, store whatever is there in a of start inside that. Next, whatever is there in start, I'll store it inside end. A of, yeah. Next, what I will do is whatever is there inside temp, I will store it inside end. That's it. Next, I will increment start, increment end. Again, I repeat, how to reverse an array, I've already taught you. If you don't remember, please go revise. That's it. Okay, now this is my reverse function. Now see, I'll scroll down to my rotate. In rotate, what I will do is, all this k value and all is fine. Here, very simple thing I'm going to do. I'm going to call reverse 3 times. First time to reverse part 1, second time to reverse part 2, third time to reverse the entire array. So for part 1, I'll call reverse first. Reverse, and there I will tell, hey, start from 0. Okay, and here maybe this if in case k is less than, okay, let that be there, no problem. I'll tell 0, comma, till where you have to go. Where you have to go is k minus 1. So start is 0, end is k minus 1. Part 1 got reversed. Now part 2, again I will call reverse. And this time I will tell the array A, please reverse it from k till the end, which is nothing but a dot length minus 1. Next, I want to reverse, the entire array. So I will call reverse, and I will tell, hey, please reverse A from 0, that is the first index, till the last index, which is a dot length minus 1. That's about it. That's about it. Will it work is the question. Now I'll come down. As you can see, first let's rotate it by maybe 3 times. Okay, now let's see whether it works. So if in case I execute, then 1, 2, 3, 4, 5. Take the first 3 elements, put it in the end. 1, 2, 3, then 4, 5. Yes, perfectly it works. I'll make that as 5, which means it should not rotate at all. Let's see whether that works. As you can see, definitely it has not got rotated. I'll make that as 7, which means actually it should rotate only 2 times. If in case I execute, then you can see 2 times it has got rotated. 4, 5. So perfectly it works. Now, why is this more efficient if you ask me? Very simple. See, you're calling reverse function 3 times. What is the time complexity of reverse? Go on top. What reverse is doing is from start till end, you are telling. Now, the only time, scroll down, that you're calling reverse from start till end of the array is this. Which means if it has n elements, n times the loop will work. This may also work n times, this may also work n times, doesn't matter. That way, if all 3 of them work till n also, it is n plus n plus n, it is 3n. 3 is a constant, it goes, which means it becomes big O of n. Previously, it was big O of k into n. Naturally, this is more efficient. I hope you're able to think. So I hope everybody will commit this to your memory, practice it, and when the time comes to rotate an array, you will remember and implement this algorithm. Anyways, my dear friends, I hope you enjoyed today's class and you learned something new, and your confidence on using arrays is increasing day by day. Anyways, let's catch up in the next class with even more exciting programs. Till then, take care. Bye-bye.